And now let's welcome tonight's special keynote speaker, Bob King. Bob fell in love with the night sky and astronomy when he was just a kid growing up in Illinois, and he loves to share his passion with people of all ages. Bob was a photographer and video editor at the Duluth News Tribune for 39 years before retiring from the paper in 2018. When he's not outside looking at comets and galaxies, he writes the astronomy blog Astrobob, as well as articles for Sky and Telescope magazine and its website. He's taught community education astronomy classes at the University of Minnesota Duluth Planetarium for many years. His books, Night Sky with the Naked Eye and Wonders of the Night Sky You Must See Before You Die, describe the joys of skywatching. Bob's third book, Urban Legends of Space, examines science versus pseudoscience in astronomy. The greatest wilderness is the one over your head, and you only need to look up. So thank you so much for joining us tonight, Bob. Go ahead, and I'll turn it over to you. Kick us off. What should we look for?
Oh, great. Well, thanks for that lovely introduction. And I swear, every time I hear the title of that second book about Wonders You Must See Before You Die, it just puts a smile on my face. It's really great to be here and to be able to share some of these upcoming events with everybody. We've got, surprisingly, you wouldn't think towards the end of a year that there'd be that much happening. It's November, December, kind of a dark, cloudy time. But I want to tell you, if the sky clears at the right times, we're going to be set up for several very, very nice events, including a couple meteor showers, an eclipse, and more. Before we go to the presentation, I do want to alert you that my internet connection is not the best. It's a little wobbly, which means my voice might sometimes also get a little wobbly. So just hang in there with me, and we'll get through this and everything will be fine. So you're probably already familiar with that from doing other Zooms and participating in other Zoom presentations. So let's continue. Let's go right to our presentation this evening. And let's see here. We will start at the beginning, of course. There's the moon. This was just from the most recent apparition of the moon, taken several days after full moon. I love watching the moon rise, I guess at any phase, but full moon is kind of the most exciting phase to watch the moon rise. And we have Lake Superior here where I live in Duluth, so it's often very enjoyable to just go down to the lake and watch that moon kind of bubble up out of the water. Here's something that I bet you have all seen in the sky probably all summer long. To the south, you probably have noticed two bright planets there, Saturn and Jupiter. Now, back in the summer, they were a little further apart. But this, where you see them here, I just took this picture a couple of nights ago, and the two planets are approaching one another right now. If you want to see them, the best time is about an hour or so, an hour and a half, maybe after sunset. I put the time down there, give or take 5:30 to 6:30. And these two planets are still in play, so to speak, and they have something very exciting for us in the coming weeks. Here we have a diagram showing you Saturn and Jupiter, their positions on September 21st, a month later, and right around now, November 21st, and then into December. You can see what's happening. These two planets are approaching one another. They were 7.5 degrees apart back in September. By the way, here's my little degree calculator. You've got one built right into your body. It's your little pinky finger. If you hold that up to the night sky at, let's see if I can do this right, at arm's length, that finger, the tip, will cover 1 degree of sky. By the way, your fist, if you make a balled fist and you hold it up, that covers 10 degrees of sky at arm's length. So you can see that Saturn and Jupiter are about a little further apart in September, getting closer and closer and closer by degrees. The arrows, take a look at these arrows. That represents how fast the planet is moving. They're both moving to the left in the sky as they orbit the sun, but Jupiter is moving more swiftly. That's why it has a bigger arrow compared to Saturn's. We're going to take a little closer look at that. Here's a view of the solar system as if we could zoom out from the Earth and look down at the planets as they orbit the sun. Here we have our friendly little Earth-like planets all huddled near the solar furnace there. And then we look far across the solar system. We look way into the distance towards Jupiter that's like 450 million miles away. And then even further than that, the planet Saturn. Now, the closer you are to the sun in our solar system, the faster you revolve around it. So for instance, Mercury only takes 88 days to complete one revolution. Jupiter, 12 years, and Saturn, almost 30. So the farther away, the slower you move. Notice Jupiter here, 29,230 miles an hour, pretty fast. Saturn, that's pretty fast too, but Jupiter is the faster of the two planets. And what we're actually witnessing in the sky, and what you'll be able to see in the coming weeks, is Jupiter speeding towards, speeding in its orbit, and it will lap, or it will pass Saturn. Let's take a look at that too. Basically, Jupiter, the faster planet, will overtake Saturn. And this happens once every 20 years. And since it's pretty infrequent, when those two planets are in conjunction, in other words, when they're closest together in the sky, we call it a great conjunction. And what's really awesome about this conjunction, all the conjunctions vary. Sometimes they're a little further apart, sometimes they're a little closer. This will be the closest one since 1623. So obviously the closest one in memory by a long shot. Let's take a look at kind of how this plays out and why the planets line up. Here we have a view of the solar system, looking from beyond it towards the flat plane of our solar system on September 28th, a month later, and finally on the big day, December 21st, which, by the way, happens to be the winter solstice as well. So kind of easy to remember that date. As we look across the plane of the solar system here, you can see that Jupiter and Saturn and the Earth and all the planets are pretty much in the same flat plane. So from Earth, as we look across the solar system, the planets line up. They appear in the same line of sight. And it's merely that line of sight, when one passes another, that creates a conjunction. And when two bright objects, like Jupiter and Saturn, or Jupiter and the Moon, line up in the sky, they make a really beautiful sight. There's some kind of a magnetic draw to that and a special beauty. So they're very wonderful to see. Plus, if you follow these conjunctions for more than one day, you will actually get a sense of how the planets revolve around the sun. All right, we see here Jupiter and Saturn, they're this far apart in September. Notice they're getting a little closer because Jupiter is speeding ahead. And November, and finally on December 21st, in the sky, it looks like they're touching. But of course, Jupiter's in the foreground, Saturn's way in the backdrop. Check this out. I've been asked, well, Bob, does this great conjunction only last one day? And the answer is yes. The actual moment or time of conjunction, when they're very close, only 1/10 of 1 degree, that's 1/10 of this, 1/10 of a degree, that happens on December the 21st. That's the moment. However, we all know that when you're looking up at the night sky, sometimes it's cloudy out, right? Our best laid plans can be destroyed by a big cloud that comes over. So the good news is about this great conjunction is that Saturn and Jupiter will be very close several days beforehand, and also still very close several days after. So you can kind of watch how they shift in relation to one another and get a real sense for their movements around the sun and their speeds. Now you'll no doubt you'll have no problem seeing the conjunction here on the 19th and the 23rd. I'm really curious how easy it will be to split those two bright planets apart. Will our eyes be able to separate them clearly? Because that's really, really close. I mean, it's been almost 400 years since they've been that close. So that will be a really fun experiment, call it, or a family activity that you can do. Just get out there, get out of the house, find a place, because this will be in December now, right? Jupiter and Saturn will have moved further over into the southwestern sky. So you're going to need to find a place in advance, take a little time, where you have a clear view low in the southwestern sky, because this happens during evening twilight. Got a telescope? Man, I can't wait for this because it's really rare to see two planets that close that you can actually squeeze them into the same telescopic field of view. Here's my little telescope. I can use this and I can fit them in the same point of view. No problem. And that particular night, the night of the conjunction, all four of Jupiter's brightest moons will be strung out in a dance line on either side of the planet. And Saturn will also have its own family of moons that are visible through a small telescope. That's just fantastic. So that's our first event, okay, involving those two planets. And it's something you can start watching now, and you can use your fingertip, that pinky, to measure the distance between those two planets and watch that distance shrink. So you can really participate in that conjunction. Merge your brain with the solar system's motions. What's the other planet that's out? You guys know. That big orange bright thing in the sky as soon as it gets dark is, of course, the planet Mars. And Mars is especially brilliant this season because it's exceptionally close to the Earth. Every couple of years, the Earth, which is closer to the sun and moves faster, right? Every couple of years, the Earth laps or passes Mars because Mars is further out. But when it passes Mars, as it did in mid-October, the two planets are closest together on the same side of the sun, as you can see here. This particular time, it's got a special word for it. It's called an opposition. And you're thinking, well, opposite, why are they opposite? Well, it's because there's a third body involved in opposition. There's the Earth in the middle. On one side is Mars, and on the opposite side is the sun. So Mars is opposite the sun in the sky. So when the sun sets, Mars rises. So that's why it's called opposition. And this occurs once every couple of years. But because Mars has this kind of weirdly squished orbit, not every opposition is the same. Some are closer than others. And this is one of the closer ones. And it, as a matter of fact, the closest that we will be to Mars right now, this fall, until the year 2035. So whenever anything is closer to you in the sky, any astronomical object, it is brighter, okay? And it's also bigger. So amateur astronomers really get pumped up when Mars is at a close opposition because finally this teeny planet, and it really is small, it's only like twice the size of the moon, this teeny planet actually looks like something through your telescope. When you go out next clear night, and maybe that's tonight, which would be wonderful. When you look at Mars, consider these few little facts. It's always a good thing to bring some additional information. Knowing the names of things is good, and then a few facts about them kind of enlivens what you see. The average temperature on Mars is 60 degrees below zero, which is, I believe, the record for Minnesota, isn't it? Somewhere around there. Whereas the Earth's average temperature is about 59 degrees. Mars is interesting, though. It has a very thin atmosphere, mostly carbon dioxide. As you can see, less than 1% of the Earth. When the sun comes up on Mars, it heats up rather rapidly. And the temperatures there, especially near the equator, they can go into the 70s. And at night, because the air is so thin, it gets really cold. So Mars is essentially a cold desert world, sort of like Mongolia times 1,000, something like that. Fascinating thing about Mars, though, is that there is current evidence of liquid water, certainly ice in the polar caps, and then much evidence of liquid water having carved rivers and other features into the Martian landscape several billion years ago when the planet had a very different climate. As I mentioned, it heats up on Mars rapidly, and it can cool down just as quickly. And so one of the familiar things you would see if you walked out of your spaceship on the planet are dust devils. They'd be ripping around out there, and you'd be blown away. Sorry, that's a bad pun, but you'd be blown away because it would remind you of Earth in that regard. Sometimes the winds on Mars can stir up a lot of dust, and the dust gets heated by the sun, and the storm becomes amplified. Isn't that a gorgeous photo of a dust storm in progress on the planet? It's amazing. You know, you may have seen the movie The Martian, and there's powerful winds knocking everything down, and you're thinking, oh my God, this is a terrifically dangerous place. Well, Mars is dangerous for wind, but for other reasons. But because the atmosphere is so thin on the planet, the power of the wind it's like a 10-mile-an-hour breeze here on the Earth. So the movie was a little dramatized, but still a really good movie. Sometimes those dust storms through feedback loops can become much, much larger and expand and cover vast areas of the planet. Back in 2018, and this is a lovely photo of the planet back in that year, we had a very close opposition of Mars. June 8th, nice clear atmosphere. You can see the polar cap up there, which is essentially dry ice, like you pick up at a gas station to keep something cold. Underneath it is water ice. Well, a dust storm got out of control and it became planet-wide. Look at that. And it just obscured all those features, including most of the polar cap. So things really get wild on Mars when it comes to dust. There are no oceans there to stop it, and it propagates very well through the thin air. I mentioned water on Mars. So when you're looking at that orange dot in the sky, try to picture in your mind's eye that rivers once flowed on this planet the same way they flow currently on our planet Earth. Here's some evidence of rivers, of erosion. You can see the looping here, some islands. These things are 3 to 3.5 billion years old, very ancient. Good news. Okay, we've sent a number of spacecraft and rovers to Mars, which you're familiar with. The current one going to Mars is called the Perseverance Rover, and that will land in February right here near this river delta. Can you see the delta? Look at this. Here's the river. This is inside a much larger crater. It's called Jezero crater. And here you can see the river has breached the wall of the crater. And look at that delta, an ancient delta. The rover, the Perseverance rover, will land on February 18th next year. And it's its own chem lab. You know, it's going to drill into this ground and sample and test and look for potential chemicals of life or even signs of life. But one of the most important things it will do is it will collect soil and rock samples. It will cache them into little containers like pencil shape, 30 some, and it will set them aside in a special place. And then another spacecraft will arrive on Mars a couple of years later, several years later, pick up those samples and then launch them into orbit where it'll be loaded onto a spacecraft there, and then that will come to Earth and those will be sent back right to our planet. So we'll actually have Martian samples that could potentially contain, I would hope so, bacterial fossils, evidence perhaps of life when Mars was much wetter and warmer, and the samples would come from that delta area. All right, so we've looked at two planets that are far out there and the wonderful conjunction happening. And then we've got the brilliant orange of Mars that's out every single night. Mars right now is still brighter than the brightest star in the nighttime sky, which some of you will know this. It's Sirius, right? That's one of the winter stars. So we're going to move now from planets to an event that's happening very, very soon. You can see here it's on November 17th, early Tuesday morning next week. We have the Leonid meteor shower. Isn't that cool? It is not normally a very strong shower. You can see that I'm only expecting 10 to 15 meteors visible per hour from a dark place. The good news is that the moon will not be out. So a lot of times the moon, when it's out, if it's bright, it kind of gets rid of the faint meteors, you know, it blanks them because of the glare. But without a moon, if you're in a dark place, you'll see about 10 to 15 meteors per hour. And when will you see them? Oh my gosh, astronomy, it just has no respect for humans sleeping. This will happen best at around 4 o'clock in the morning on the 17th. You can go out at 3, 4, and 5 to see this shower. And it radiates, the meteors will appear to be streaming from a point in what's called the sickle, like one of the old farm implements that's used to cut grain, called the Sickle of Leo. And here's our lion. There's the sickle, which is also his head. And here's his tail back here. So right there in the middle of the sickle. This is if you watch. If you watch meteors, you can look anywhere in the sky you like, but they will all point back to Leo. If they point back to the eastern sky, to Leo, then you know you're seeing a Leonid. When I watch meteor showers, I'm often asked, what direction is best? And I say, don't stare straight at the radiant, because a lot of the meteors in that direction will be short, little sparks. So if you would look off 45 degrees to one side, you could look to the southeast in this case, because Leo is in the east at that hour, or you can look to the northeast and then just kick back and wait and watch. What are you seeing when you see meteors? Well, this is just amazing. This is how the solar system literally touches the Earth. That it really tells us that we are not isolated in any way, that we are a member of the solar system, because things from the solar system are actually touching the Earth during a meteor shower. Comets, which are made primarily of ice, but they're impregnated with dust and small rocks, kind of like the size of grape nuts. Comets, when they pass near the sun, part of that ice will vaporize and it will release that dust. And that dust and those little pebbles will still follow along the orbit of the comet. So every comet has its own dust trail as an orbit around the sun. And sometimes comets leave extra amounts of dust when they pass near the sun, sometimes not as much. So it's a little uneven, but that trail is always there. It's like zillions of tiny dust motes and small rocks orbiting the sun. The particular comet responsible for the Leonid meteor shower is Comet Tempel-Tuttle. And it's about a couple kilometers across, this icy mass. And when it's near the sun, then part of it vaporizes. And some of that material spreads out into the orbit. Here's the orbit of Comet Tempel-Tuttle right there. And here's Earth's orbit, okay, that blue oval. Every mid-November, the Earth goes right through that orbital debris. It intersects it. And when it does, it's exactly as if you're in your car driving through a snowstorm at night. Picture the headlights shining ahead. It looks like snowflakes, if you're driving, appear to be streaming from a point in the distance, and they hit your windshield, right? In the case of a meteor shower, the Earth is the car, and it's streaming through orbital debris, and the windshield is the atmosphere. So meteor, or little bits and particles from the comet, strike the atmosphere at tremendous speeds. The Leonids, oh my gosh, they're like more than 150,000 miles an hour. When they hit, they burn up, they vaporize, and they create a glowing trail of light. And that's what a meteor is. Now, I did say that the Leonids were a minor shower, but that's not always true. Sometimes the Earth will encounter a thicker filament of material, and this happens approximately every 33 years. Now, and when it happens, instead of 10 per hour, you can see up to, like a couple thousand. There's several thousand per hour. This is a lithograph from the 1833, what we call a meteor storm, because it's not just an ordinary shower, but the Earth passed through a thick filament of material. And in 1833, it rained meteors. So people were just out on the street. In 1966, this happened again. And someone was quoted as saying, "I felt like I had to have a hard hat on because I thought I was going to get hit." You don't have to worry ever about getting hit from a meteor in a meteor shower, because the material is really quite small and it all burns up in the atmosphere. We still have yet to find an actual meteorite, in other words, a chunk big enough to make it through the atmosphere and hit the ground. We haven't found one of these from any meteor shower yet. The next one, though, I'm afraid it's going to be a while. The next really big storm probably won't happen until 2099. All right. Some of you might be skeptical. Some of you have experience and know that sometimes it is cloudy during meteor showers. You might miss it. So I've got a wonderful site for you, and you can check this out anytime. Meteors are constantly arriving in the atmosphere, not at the shower rate, but every day, hundreds of thousands of small bits from comets and asteroids are peppering our atmosphere and burning up. Some are big enough to make it through as meteorites. Go to this website for fun. Just turn it on. It has a little arrow like you would see on YouTube down here. You click the arrow, and then you are listening to a radio signal being bounced off a meteor trail, and it produces a sound. It produces a radio sound, and you can hear meteors at this site. And if you just leave it on in the background, you'll hear an occasional low whistle. But it would be fascinating as a little bit of an experiment to listen to it now when there's no shower, and then maybe tune in on Tuesday morning and see if there are a lot more meteors. So you could actually listen. And each meteor that occurs not only makes a sound, but it makes a blip down here on the readout. So livemeteors.com, great place to check out. I probably get more questions about the Northern Lights than anything. When can I see it? Where can I see it? Sometimes people from Minneapolis, I live in Duluth, they'll say, hey, where's it happening? Where should I drive? And I always feel a little sheepish because the Northern Lights are so sketchy sometimes. You can have a great forecast, but then it doesn't materialize, or it happens 6 hours before, or it happens at 6 o'clock in the morning. So I do have some good news about a potential upcoming aurora event, though. And it's certainly absolutely one of the most beautiful things you can see in the nighttime sky. There is nothing to compare to the Northern Lights, to a true full sky display. Maybe there's a total eclipse of the sun, but I think that's it. We had a lot of excitement in the past week because we had the first big sunspot group of the new cycle. The sun goes through this cycle of activity where it peaks and then activity drops off, and then it peaks again, and the cycle lasts 11 years. We're currently moving into the new cycle. So we all had our hopes up. Wow, maybe something exciting will happen in this group. Maybe there'll be a solar flare. And it's flares that often produce the material, that shoot the material out from the sun towards the Earth, that spark the displays of the Northern Lights. Let's take a look at what flares can do. So during high solar activity, flares are common, and they drive the Northern Lights. And what we see here is the sun is just this amazing ball of electrified gas, I guess, ionized gas. And it also, because it's moving, has a lot of magnetism to it. And that magnetic energy that's part of the sun becomes concentrated in those sunspot groups that you saw. And the sun's surface, while it looks nice and still and steady to our eye, if you could hover above it, it would be like your face over a pot of boiling oatmeal or boiling water, just bubbling and churning. Well, the powerful magnetic energy in those solar flares gets twisted and turned and crossed. And when it happens, there's a tremendous release of energy. And that's what a solar flare is. I was checking into solar flares. A typical one is equal to the explosion of 2.5 million hydrogen bombs of 100 megaton power. The largest bomb ever exploded here on Earth was only 57 megatons. So this is 2.5 million. And a really big flare is millions of those bombs. Good thing it's 93 million miles away, right? Nice, safe distance. We're safe to a point, though, because if that flare is directed towards the Earth, it can shoot particles towards us. And if those particles are sort of aimed in the right direction, they can link into the Earth's magnetic bubble. Here you can see it right here, the blue curvy lines, sort of resembling the iron filaments around a magnet, can link in and then stream down rapidly and strike the atmosphere over our heads. Thank goodness we have an atmosphere, right? Or we'd get pinged by those very electrons and protons that the sun is sending out. Very high speed, hits the molecules up there, oxygen, nitrogen, and it causes them to glow and produce beautiful pinks and greens and sometimes blue that create the Northern Lights. I mentioned that flares were important during the peak times. During low solar activity, such as we're in now, there's some other thing that happens on the sun called coronal holes that cause the northern lights. This is the sun's corona or atmosphere photographed in far ultraviolet light by NASA's space or sun orbiting observatory. And you can see these big dark areas in there. Here is where these particles from the sun in those holes can literally stream out at high speed, almost acting like a flare. And those particles can reach the Earth and sometimes cause the northern lights. Here's a wonderful magnetic diagram showing you the coronal hole and these very magnetically strong areas where sunspots are. They kind of braid and knit the magnetic field to the sun. But the hole just says, let it go. And it blasts it out at many hundreds of kilometers per hour. Well, a coronal hole that is coming back around again because the sun rotates. It takes about 4 weeks to go around once. A coronal hole will be pointing towards us. And we might possibly get the aurora between November 20th and November 22nd. It's not a massive storm, but it would probably be visible in the northern United States. So we have two ways for that to happen: coronal holes and flares. We mostly depend upon those holes. And because the sun rotates, like I said, about once every 4 weeks, coronal holes, they last a long time, often many months. So if you see the northern lights in late November, there's a good chance when that hole comes back around in December, you'll see them again. Moving further into November, we're going right up to the end of the month now. On Monday morning, November 30th, we have a penumbral eclipse of the moon. Now, maybe you've seen a lunar eclipse, a partial eclipse, or a total eclipse. During those eclipses, the moon passes through the darkest part of the Earth's shadow, called the umbra. If you were inside the umbra and you look back towards the sun would be completely hidden by the Earth. So that's why the shadow that the Earth's the umbral shadow is quite dark. And that's what gives us partial and total lunar eclipses. But the moon occasionally passes through this outer shadow you see here called the penumbra. And from within the penumbra, Earth only blocks part of the sun. So you got some sunlight leaking in there. So you get a mix of sunlight and shadow. So there's still kind of a shadow, but it's not the dark, nice, hard, the shadow that you would see during a normal eclipse. And the reason why the moon doesn't always pass through the umbra during a total eclipse is because its orbit is tilted. As a matter of fact, it's tilted like 5 degrees. And so when the moon, during most full moons, which is when lunar eclipses occur, the moon is actually above both the penumbra and the umbra, or below them. This time it's just deep enough into the penumbra where we'll be able to see the eclipse. Here's a penumbral eclipse. This is a good example. We had one back on February 10th, 2017. Can you see the shadow on the moon? I bet you can. I'll point it out in case you have any difficulty. Right here, that's the penumbral shadow. And we'll see something like this again on the morning of the 30th. I've got the times off there on the side for you. And of course, once again, 3:45 in the morning. Oh my gosh. Well, easy way to do this is just to get up, look for 10 or 15 minutes, just kind of part the drapes. I'm not beneath this. I don't always go out. I'll just open the drapes and take a look. And you should notice if you go out at the peak time when the majority of the moon is in the shadow, as you can see here in the diagram. If you go out around 3:45, you will notice a strange grayish blunted look to the moon. It's really fascinating. Take a look at that. That's November 30th. Well, I didn't just have one meteor shower planned for you. I got two. Now, if the Leonids is a minor shower, the Geminids is not. The Geminids is really an awesome shower. Matter of fact, it is the best meteor shower of the year. It surpasses the Perseids. You know, the Perseids, the one that shows up in August, the easy one to go out and watch. You just lay on the dock at the lake or whatever, and what fun. But this one actually has more meteors. You will read online that 100 meteors per hour are visible. That is sort of an idealized number. What I like to do with meteor shower numbers is sort of reduce them based on real life situations. You know, we all have to deal with some amount of light pollution. So I usually cut them in half or maybe take a third off of that number. So the Geminids, and again, the moon won't be on this one either, so we'll be able to see the faint ones too. You might see 50 to maybe 80 per hour if you're in a dark place. If you're in a somewhat light polluted area, you might see 30 of these guys per hour. The other good part about this one, finally, we have an event that's happening where you can go out at 10 o'clock in the evening. Gemini is up and visible in the evening sky on the night of the 13th and the 14th. The later you stay up, the higher the radiant rises. So the ones that are falling below the radiant won't get cut off by the horizon. So the higher the radiant is, the later you stay up, the more meteors per hour you'll see. Unlike many meteor showers, the Geminids occur when the Earth passes through a debris trail, not left by a comet, but left by a very peculiar asteroid called Phaethon. It's a great name to say, Phaethon. And here is the orbit of Phaethon. Passes very close to the sun. It is thought that the heat from the sun has dried and cracked the surface of this asteroid and liberated chunks of it into space to form a trail. And every December 13th, we pass through that trail. Here's the Earth, moving on through, right there. And that's how we see the Geminid meteor shower. So it's a bit different from most of them. Again, 50 to 80 meteors per hour are visible. The radiant point is near these two stars, Castor and Pollux, the Gemini twins, above the constellation of Orion the Hunter. And the speed, they're slower than the Leonids, but fast enough, trust me, 79,000 miles an hour, a lot faster than my Honda can go. One of the great joys about meteor showers is just, it is the most relaxing thing that you can do. There, obviously, that's me down there. I'm more comfortable actually than I look in the photograph. I bundle up with everything. I've got the heavy boots on, the gloves, and then I get a nice heavy blanket over and just lay back. It's so easy. And I'll count them just casually. You know, you can participate in meteor watching and counting programs if you want to do some citizen science, or just do it casual. Just go out and enjoy lying out under the stars, watching the slow drift of the stars as the Earth rotates. And then now and again, in that very slow rhythm, here comes something very fast. And it is so exciting to see a meteor just spear its way across the sky. I hope it's clear, and good luck to you on the Geminid meteor shower. Well, we're not done with the eclipses either. As we move to the middle of December, on the 14th, there will be a total eclipse of the sun. Maybe some of you drove out west or flew out west to Wyoming or Nebraska to watch the August 2017 total solar eclipse. And I hope it was clear for you then. Well, I love that eclipse so much that I decided I would want to see this one too. This is not occurring in the United States. This photograph, by the way, shows the moon, which is what's covering the sun during a total solar eclipse, right? Here's the Earth right here. The moon moves between the Earth and you're the sun, and then it moves away. So we're actually seeing the moon right here. And then the material around the sun in the corona, this sort of really looks like the way the sun's corona does in a pair of binoculars during totality. The magnetic field of the sun, just like a powerful magnet on the Earth, is directing the particles around the sun into these magnetic field lines, these beautiful brushes. And this photographer used special filtering to capture that. Where's this eclipse happening? Oh, way far away, 10,000 kilometers away. The path of totality goes through Chile and Argentina. And there's some great areas here for viewing near the Andes Mountains and down here on the high plains of Argentina. I even bought a ticket to this. I have a friend down there and was going to meet another friend. We're going to drive to the center line, watch totality. And then due to the virus, I'm sure, the Delta Airlines gave me an email and said they had to cancel the flight. So unfortunately, we'll not be seeing this eclipse. I'll have to wait till 2024, right, when the next eclipse occurs across the United States, the next total eclipse. However, I have learned that there is joy in watching a total eclipse online. It's not like being there, of course, but it's in real time when it's live streamed, and it can be surprisingly moving. The Exploratorium, I believe it's in San Francisco, was going to live stream the eclipse, and I put the web address there for you. You can just look up Exploratorium December eclipse too. You can just Google that and then bookmark that and be there and watch this on the afternoon of the total eclipse of December the 14th. Now, I wanted to take a minute to give you some resources, because as much as I'd like to be your personal guide out there at your side, using our fingers to kind of work our way around the sky, or sharing my telescope with you, how much I really would love to do that. I want to give you resources so you can do this on your own. One of the things that I like is the Evening Sky Map, and it's free every month. It's available at skymaps.com. And what you get is a star chart for that month. All right. Pardon me. And then to the left of it is a list of sky events. And if you go down here, you're going to notice, oh, there's the Leonid meteor shower. So this can be just a handy reference, something you can keep around you, right? And it's a free one, comes up at the end of every month for the next month. Just go to that website. Also, each one of these events that I've talked about, and many more smaller ones, I'm going to feature in my blog, which is called Astrobob, with a space in between, lots of space, because I'm a spacey guy. Another thing, if you do not already have this or use it, I think you will just be delighted to use a star chart app on your phone, where you can take your phone once you load it, and it's called Star Chart, and you can get it for your iPhone by Googling iPhone Star Chart app, or for your Android Star Chart app. Pretty easy, right? Once you load it, you hold it against the sky, and it will show you the stars that you're seeing. And if you want to know what's what, you just tap it, and then a little info box comes up. You can also touch the screen and move it around and change the time so you could see what's happening 3 nights from now, or in the year 5000 AD or 5000 BC. There's tremendous flexibility in this. Also shows the planets. So that's really, really handy. We can't do a whole lesson on this right now, but just to alert you, if you use Star Chart or another app, go into the settings. And in settings, you're going to see a night mode setting. Be sure you click on night mode, and this is what you'll see. Your screen will be red, and that red screen preserves your night vision. You don't want to be looking at a bright blue screen, right, when you point it at the sky. You won't see any stars. But this way, you're able to see the stars at the same time you can read the screen. Now, this part of the presentation, I'm sneaking it in. All right, I wanted to talk about sky events to the end of the year, but I got to thinking and realized that, well, Christmas is coming up. This might be a nice time to make a recommendation to you if any of you are interested in purchasing either a pair of binoculars or a telescope. And there's a zillion different scopes out there. So I've got a couple of recommendations that you might find helpful. First of all, we start with what to avoid. Oh my gosh. How many of you, this is actually something similar to what I started with when I was a kid, when I was about 11 years old. And I don't even know how I got through this and made it into astronomy, because it was just, this telescope was my barrier to the sky. Wobbly mounts, a cheap plastic focuser, very narrow field of view. Once you point it at something, it drifts away, and then it's next to impossible to find again. You'll often find these in kind of big box stores. The price is reasonable, maybe $30, $40 or so. But I hope you can spend a little more money on something that you will actually enjoy for your lifetime. I bought a 6-inch telescope back when I was 12 years old. I still have the thing, and it works great. I mean, they're like bicycles, you know, they last forever if you take care of them. So let's look at a couple of things that would be helpful. Here is, and you can never go wrong with a 6-inch telescope, I think. This is a 6-inch Dobsonian scope. And here it's called Dobsonian because the mount down here was invented by a guy named John Dobson, a former monk who went rogue and decided he wanted to share the sky with everybody. And so he built giant telescopes on really simple, stable mounts like this and shared astronomy across the country. He used to go to a lot of national parks. Anyway, this is John's design. And here's the tube, and the tube is the mirror down at the bottom. And in the middle, there's another mirror. Light falls in through the top of the tube, bounces off the mirror in the bottom, bounces back to the mirror in the middle. That shoots it out the side of the tube, and you stand at the side to look through the eyepiece. This is around $315. I've got a couple of websites you can check out: B&H Photo, astronomics.com, and highpointscientific.com. It's the same price at every place. Another really nice option for a 6-inch telescope with that similar type of simple, stable mounting. By the way, this unit is not large. You can literally pick the whole thing up like this and set it down very easily. I don't know, it's 20 pounds or something. Super easy. It comes with a couple of eyepieces. This one has a little laser dot finder. You project a red dot against the sky, and you put that red dot on what you want to look at. And then it'll appear through the eyepiece. So very similar, a little less money, free shipping, can't go wrong. If $300 is too much for you, here's a smaller Dobsonian style mount, but it's a 4.5-inch telescope. By the way, the size of a telescope in inches, that is the diameter of the mirror in this case, or in the case of a refracting telescope, the one that you look through like this, the diameter of the glass lens or objective, it's called, at the end. So this is a little smaller, and it's on a small mount, so you could put it on a table or a picnic bench and use. Quality optics, nice sharp views, that's what you want. And still good light gathering power. You know, you can see brightest galaxies, you can see the cloud belts on Jupiter, no problem with Saturn. If that's too much money, and I think you should have this in your astronomical arsenal anyway, is a pair of binoculars. I've got a couple of pairs, I really love them. I find that they just give such beautiful views of the moon, especially when the moon's a crescent and you can see the bright crescent and then the Earth-lit dark part of the moon. It looks so three-dimensional through binoculars. Gorgeous. They're great for craters. You can see them in binoculars. Conjunctions, Milky Way vistas, unbelievable. And you will see thousands more stars in the Milky Way because they have that light gathering power. They've got the lens that pulls in the light. You can even see the brightest galaxies, double stars, and get beautiful views of star clusters like the Seven Sisters, for instance. I recommend the 7x50. 7 is the magnification. 50 is the diameter of the light gathering lens in millimeters. So 50 millimeters or 2 inches, or 8x56. And here are a couple of suggestions for you. The Opticron Adventurer, 10x50, and the Nikon 7x50 Aculon. And with that, I'm back at you here. And if you do have any questions, just feel free.
We do.
Great.
So for starters, we'll be able to see all of these night sky events here in Minnesota. Now, you covered a lot, and I think the only one that I heard that you can't see is which one?
Total solar eclipse.
Okay, but everything else is visible from here in Minnesota?
Everything is visible from Minnesota. As a matter of fact, all of those things are visible across the entire United States. So if you happen to be on vacation, no worries. You'll be able to see it anywhere, in Europe as well. So, yeah, we're all good. The only place, like any total solar eclipse, it's only in a very specific narrow path, like I showed in the image. So you got to be in that path, and that goes through Argentina.
Okay, so we have another one. This one is from James, age 6. Can we see the meteors without a telescope?
Yes, James, you certainly can. And I hope you see a whole bunch of them. That is one of the other things that's so great about a meteor shower is that you don't need any equipment. Well, unless you call a nice lounge chair equipment, you just need a chair to spread out in and a blanket, and you just lay back. And that is also one of the great joys of meteor shower watching. No special equipment.
Okay, another one related to meteors here. This one is coming from Susie and Becca. If an asteroid keeps flying by and the Earth goes into all that dust field, will the asteroid eventually become nothing?
Or you mean the phaethon? Will it become nothing? I guess that's a possibility because it does lose material as it's heated by the sun. So it is possible that it could break apart one day and just crumble. We know that comets crumble. Sometimes they get so close to the sun that the heat from the sun and the gravity of the sun will actually break them up into pieces. That's why some comets, even though they're forecast to be very bright, if they pass really close to the sun, they can get disrupted, busted apart, and that's the end of the show. So it is a possibility, yes.
Okay. So one about what kind of telescope do you use?
I have too many telescopes for many different purposes. Can I show you the one I use for the sun, for instance?
That would be a lot of fun. Yes, we'd enjoy that.
Here, as a for instance, this one I use, it's a little well, there it is, right in my face. There you go. It's a little refracting telescope, so it has the lens right here on the end, and it's on a tripod. What I do is if there's an interesting sunspot, I take my solar filter, I place it over the end. I just leave this at the ready. And so I can just put it out in the driveway, point it at the sun, and look at those sunspots within a minute. I also have a large telescope. It's quite a bit bigger than this. It has a 15-inch mirror. That's the largest scope that I own. And I bring that out when I want to see lots of detail in galaxies, or I'm looking for fainter comets, and I'll drive that one to the country so I have a really dark sky and I can make the best use of it. And I've got a few other ones too. I think maybe 10 of them altogether. I can't help it. Telescopes are indestructible and you can find a purpose for every single one of them. So yes, I have several. The largest is 15.
Oh, wow. Speaking of the sun and the solar scope you're just holding there, how does a solar flare have magnetic energy in it? This is coming from Ellie and Henry.
Ellie and Henry, a wonderful question. Here, let's launch into a long talk about solar physics, but no, let's not. When you have the sun, the gases on the sun, it's so hot there that the gases are sort of electrified. And if you move electrical material around, because the sun's bubbling and burbling all the time, it creates magnetism at the same time. And that magnetic energy gets concentrated into sunspot groups. And if it really gets intense within those sunspot groups, that's what causes flares, because a magnet has a south pole and a north pole. And if those poles touch or get wrapped around each other inside the sunspot, kaboom, it's like two wires touching. So moving electrical gases create magnetic fields, and then those in turn get concentrated and can sometimes lead to flares. You can actually see this for yourself. If you take a battery and hook two wires to it and then pass electric current through it and put your compass near those wires, you will see the needle deflect because there's a magnetic field running through those wires when it's hooked up to a battery. Great question. Thanks, guys.
Okay, so we probably have time for one more here.
Oh, sure.
And this one is also about the sun. This is from Vivian, age 8. What is the sun burning? Is it burning rocks or a certain gas?
Oh, Vivian, I love that question. Thank you for asking that. 100 years ago, more than 100, people thought it burned coal because that was like the thing that people used to heat their homes. But no, the sun, it's actually not burning anything. What it's doing is that the pressure and the heat inside the center of the sun is so high that it's crushing atoms of hydrogen together so close that they make a brand new element called helium. And if you've ever seen a helium balloon, you know, the ones that float, helium is inside there. When hydrogen gets crushed and fuses together, we call it, to create helium, it gives off a little bit of energy every time two atoms come together, or several atoms. And that energy, because you got millions and millions, trillions of atoms in the sun, you have lots and lots of energy being created in the core of the sun, where it's super hot and super dense. That energy then leaks out to the outside of the sun, and you're not going to believe this. The sun is so big, and that energy has to pass through so much gas on its way to the surface before we can feel it as heat. It takes 10,000 years for the heat in the center of the sun to get to the surface. So when you're out the next sunny day and you can feel the sun on your cheek, that happened a long time ago.
Okay. Well, you have plenty more questions coming in, and unfortunately, we have to let you go because this is awesome, but we have other cool things happening. So thank you so much for joining us, Bob. We will try to keep answering as many questions we can in the chat or in the Q&A box, excuse me. So we won't forget about the answers that are still coming in. Bob, if you're willing to, if you want to type in answers to those, you're welcome to on the board.
Sure, I'd be happy to. I'll do my best.
Okay.
Keep going.
So thank you so much for joining us, Bob. It was very informative, and we will have links to resources on what's coming up in our night sky, some of which Bob has shared with us on our resource page on the Statewide Star Party landing page on the Bell Museum's website. So thank you, Bob. Have a wonderful weekend. We really appreciate having you here.
Thank you, Sarah. It was a lot of fun. I appreciate being here.
Have a good night.